Hello, this is Mr. Stansbury. I'm going to take you through the 14K assignment. All right, so the first one we have is number 2. In a class of 40 students, 23 have dark hair, 18 have brown eyes, and 26 have dark hair, brown eyes, or both. A child is selected at random. Determine the probability the child has, and we've got all these different ones to figure out. Okay, I am going to suggest to do a Venn diagram, so let's try that out. Okay, so here's what our Venn diagram could look like. Dark hair, brown eyes. Okay, so it says 23 have dark hair, so that's 23 in here. 18 have brown eyes, so there's 18 in these two sections here. And it says 26 have dark hair, brown eyes, or both. So that would be all three of these here. So we can figure out how many have neither. So that would be 40 minus our 26 give us 14. So we have 14 out here that have neither dark hair or brown eyes. Okay. So what we can do is say, let's see, we know that there's 26 total in these three regions here. So if we have 23 that have dark hair and we have 18 that have brown eyes, we add those two together and that gives us that we have 41. 41 if there was just dark hair and just brown eyes but not both. Now we know that there's some crossover, so we take that 41 and subtract our 26 and find out that there are 15 that we've counted 15 too many. So that means that there's 15 that got counted twice, so there's 15 in the middle here. Okay? So we got 15 that have dark hair and brown eyes. So if it says 23 have dark hair, so we have 23 minus 15 gives us that there's 8 that have just dark hair. And then if we have 18 minus 15, that gives us that 3 people have just brown eyes. Okay? Now let's double check to make sure that this all adds up to 40. We've got 8 plus 15 is 23, plus 3 more is 26, 36, that's 40. And that's what we need to have. So at least our numbers all work out right. Okay? Now part A, determine the probability that the child has dark hair and brown eyes. So dark hair and brown eyes, that's the middle number there. So that's 15 out of 40. Those are both divisible by 5. So that's 3 out of 8. Okay. B, neither dark hair nor brown eyes. That's the people that are outside of both of those. So that's 14 out of 40. Those are both divisible by 2. And that's 7/20. Okay. Part C, dark hair but not brown eyes. So we got dark hair here but not brown eyes. That's 8. So that's 8 out of 40. Both divisible by 8, so that's 1/5. Right? And then D, have brown eyes given that the child has dark hair. So again, this given that the child has dark hair, that means we are now only looking at the dark-haired people. We're not concerned with those that have brown eyes, just brown eyes, or have neither. Okay, so these are the only people we're even talking about in this question. So given that the child has dark hair, so that's 8 plus 15, that makes our denominator 23. How many of these have brown eyes? Okay, given that they have dark hair. So that's those 15 people here have brown eyes. So it's 15 out of 23. And oops, you can't reduce that, so we just leave that. Okay? All right, next problem. We have number 4. 30 students sit for an examination in both French and English. 25 pass French, 24 pass English, and 3 fail both. Determine the probability of that a student who blah 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 blah. Again, I just think that these are much easier with a Venn diagram, so I'm going to draw one of those. Okay, so here's our Venn diagram. It's 30 total. 25 pass French, 24 pass English, and 3 fail both. So we know that there's 3 out here, and there's 30 total. So 30 minus 3 is 27. So we know that these 3 regions here all have to add up to 27. If we add the 25 that pass French and 24 that pass English, 25 plus 24, that gives us 49. Okay, so if we take our 49 minus, we know that there's only 27 in here. It gives us that there's 22 people that got counted twice. So that means that there's 22 that pass both English and French. Okay, so if 25 pass French, 25 minus 22 gives us that there's 3 that only passed French. Okay, and then 24 pass English, so that's going to be 24 minus 22. That gives us that there's only 2 that passed English and not French. Okay, so A, determine the probability that a student who passed French also passed English. So again, if they passed French, then we're only looking at the people that passed French. So that's only 25 of these 40 total people. So how many of those people that passed French also passed English? That's these 22. So it's 22 out of 25, right? And I don't think that those are, I don't think that we can reduce those. So we're just going to leave that there. And then part B says, determine the probability that a student who failed English passed in French. So the people that failed English would be these people here. Okay, so let's do that. So the people that failed English are these 6 people, because all of these people over here passed English. Okay, and how many of those also passed French? So it's 3 out of those 6 total. So that means it's 1/2 of them. Okay, all right. Moving on to number 6. In a certain town, 3 newspapers are published. 20% of the population read A, 16 read B, 14 read C, 8 read A and B, 5 read A and C, 4 read B and C, 2 read all 3 newspapers. Okay, so now we're talking about A, B, and C. We've got 3 different newspapers, 3 different things that they're talking about here. So let's make a Venn diagram with 3 circles, 3 loops. Okay, so it could look something like this. Now, this is a tough one because they've given us a whole bunch of different things that we need to figure out here. So here's the part that I think is most helpful. If I can find the middle number here and start working out into these other pieces here, that usually seems to be the easiest way. And we do know that 2% read all 3 newspapers. So we know that there's, let's just go with just percents in here. So we know that there's 2% that do all of those. So we got rid of that one. There's 4 that read B and C. So there's 4 total in these 2 regions here. So 4 minus 2 leaves us that there's 2 more that read. So we have 2 that read just B and C. Okay. 5%. Let's see. 5% read A and C. So there's 5% in these two regions here total. So there's already 2 there. So that means there's 3 more here. Okay. So I'm just kind of reading it backwards, if you'll see. 8% read A and B. So A and B together, these 2 regions here have to be 8. So this is going to be 6. 6 plus 2 gives us 8. Okay. 16% read newspaper B. So there's 16 total in all 4 of these regions here. So 16 minus 6 plus 2 plus 2. That's 6, 7, 8, 9, 10. So that's going to give us that this here is going to be 6. Let's see. That was 16% read B. 14% read C. So 14 minus 3 plus 2 plus 2. Let's see. 3, 4, 5, 6, 7. So 14 minus 7 gives us 7. So that's going to be those. And then 20% read A. So that's going to be 20 minus 6 plus 3 plus 2. 6 plus 3 plus 2 is 11. 20 minus 11 gives us 9. Okay, so now we've done all the hard work. We've figured out all of these here. Okay, so let's see. But actually, we haven't figured out the outside piece of who doesn't read any newspapers at all. So in order to figure that out, we're going to need to add all these. So we've got to add all these up and see. It should end up equaling 100%, right? So let's do this. Let's do 100 minus all these numbers. 9 minus 6, minus 6, minus 3, minus 2, minus 2, minus 7. I believe that's all of them. 65% don't read a newspaper. What's wrong with these people? Let's double check. 9 plus 6 is 15, plus 6 is 21, 22, 23, 24, 25, plus another 10 is 35. Yep, 65 people don't read a newspaper at all. Slackers. All right. Anyway, determine the probability that the person reads none of the papers. Good, we figured that out. 65 out of 100. Those are both divisible by 5. So that's going to be, let's see, 13 out of 20, right? Okay. Part B, at least one of the newspapers. So at least one of the newspapers is going to be the other 35. So that's 35 out of 100. Divide both of those by 5. And we get 7 out of 20. Right? C, exactly one of the papers is going to be the 9, 6, and 7. So that's 9 plus 6 plus 7 over 100. So that's 15, 22 out of 100, which is 11 out of 50. If we reduce it down. Okay. D, either A or B. So that's going to be everything in the A circle and the B circle. Okay, or the B circle. So let's see. We've got here. You know what might be easier? Look, there's these two numbers are not in that, and we know that we have 100 minus the 65 and the 7. Out of 100 total. So 65 and 7 is 72. 100 minus 72 is 28 out of 100. Those are both divisible by 4. So that's going to be 7 out of 25. Right? Okay, so 7 out of 25. Let's see, part E. Determine the probability that the person reads A, given that the person reads at least one newspaper. So now we're talking about only these 35% of the people. So we've got 35 here, and then how many reads newspaper A? Okay, so that's going to be the, let's see, well actually it says right here 20% read A, so there's our 20 out of 35. Those are both divisible by 5, so that's 4/7. Okay? And then F, we've got how many people read C, given that the person reads A or B or both. So that's going to be just this group of people right in here, because all those people read A, B, or both. So it's going to be everything except for these 65 and 7 people, which we figured out is 28 total. So we know that there's 28 people that read A and B, right? So we've got, let's see here. So of those 28, how many of those people read C? So C, or that's this circle here, so 3, 4, 5, 6, 7. So 7 out of the 28, which reduces down to 1/4. Okay? Okay, moving on to the next one here. We've got number 8. Urn A contains 2 red and 3 blue marbles. Urn B contains 4 red and 1 blue marble. Peter selects an urn by tossing a coin and then takes a marble from that urn. Determine the probability, so forth and so on. So, honestly here, I don't think a Venn diagram is going to be very helpful, but I think a tree diagram would be more helpful. So, let's do this. We've got urn A, or they could choose urn B, right? And it's a coin toss, so it's 0.5 to get A, a 0.5 to get B. Okay. Now, let's see. If urn A is chosen, you can either get a red or a blue marble, and same thing with B. You can either get a red or a blue marble. So the probability in urn A of getting a red marble is 2 out of 5, so that's 0.4. Urn B is 0.6 then, right? Because those have to add up to 100. And then urn B contains 4 red and 1 blue marble. Okay, so urn B, the red marbles are 4 red and 1 blue, so that's 4 out of 5, so that's 0.8. And then for the blue marbles, that's going to be 0.2. Okay, so determine the probability that it's red. So that's going to be, so for part A, we've got 0.5 times 0.4 plus our 0.5 times 0.8, right? That's the 2 paths to get red. So 0.5 times 0.4 is 0.2. 0.5 times 0.8 is 0.4. Add those together and we get 0.6, or 60%. Either one of those is fine. The book actually just left it as a fraction because they did 1/2, and then they did these in fractions instead of decimals, but this is just fine. Okay. B, given that the marble is red, so that's these here, so we know that for sure it's red. What's the probability that it came from B? So this is the probability, best way to describe this? Okay, so we know that for sure it came from the red, so that's the 60%. So I'm going to do this. I'm going to put 0.6. Okay, so we're talking about given that the marble is red. So we're only talking about this and this. We don't care about these down here at all. So that's the 60% that we just figured out, right? So what's the probability now that it came from B? B was 0.4. So it should be 0.4 out of 0.6, right? Which ends up being 0.4. That's 0.667, or 66.7%, which is really 2/3. So any one of those is just fine. Okay, moving on to the next one. Number 10, sociologists examine the criminal justice system following exhaustive interviews with which included the use of a lie detector test results. She published her findings. Her results were given on a tree diagram. G is guilty, G prime is not guilty, C is convicted, C prime is not convicted. Okay, so it's nice they've actually got it all filled out for us. We don't have to do anything there. What percentage of people were correctly judged? So these were the guilty that were convicted, so it would be this one here. Right, so that would be, let's do this, 0.83 times 0.95. Okay, so gotta turn it on, 0.83 times 0.95 gives us 0.7885, so 0.7885. And let's see, so these were the people that were not guilty and not convicted. So that's going to be this one here. So that's 0.17 times 0.99. So 0.99 times 0.17 gives us 0.1683. So what percentage of people were correctly judged? It's going to be these two added together. So A is going to be 0.7885 plus 0.1683. So add that to 0.7885, and we get that 95.68. Okay, so 95.68% of the people were judged correctly. I would hope that would be 100, but apparently it's not. B, what's the probability of convicting a person given that they are guilty? Okay, so given that they're guilty, so we're just talking about that here, what's the probability of convicting them? That's 95%, isn't it? Yep. So given that they're guilty, so we're just looking at these two sections here, and it says what's the probability of convicting them given that they're guilty? That's just 95%. So there's really not anything to calculate out there. Okay. C, what's the probability of acquitting a person given that they're innocent? So given that they're not guilty, what's the probability that they are not convicted? That would be 99%, 0.99, right? D, which of the answers to B and C would you prefer to be the higher? Oh wow, that's kind of your own own choice in that one, isn't it? Yeah, I'm gonna leave that one alone. E, what's the probability that a randomly selected person on trial will be convicted? Randomly selected person on trial will be convicted. So there's convicted, there's not convicted. So we need to figure out these two here. This is the probability that people will be convicted. So this is 0.17, 0.01. All right. So 0.01 times 0.17. Not sure why you needed the calculator for that. 0.0017, right? Because you just got to move the decimal over 2 more spots. Okay. So E, with probability that a randomly selected person on trial will be convicted. So that's our 0.7885 plus 0.0017. So we add those two together. 0.7885 plus 0.0017 gives us 0.7902. 7902. All right. And then F. What is the probability that a randomly selected person on trial is guilty given that they are not convicted? So we've got, it's going to have to be this one here, right? What's the probability that a randomly selected person on trial is guilty given that they're not convicted? Oh, okay. So here's the guilty people that are not convicted. So we really got to figure out both, like, given that they're not convicted, we got to figure out the two not convicteds and then figure out which one of those is guilty, right? So we have to figure out what this is here. So this is 0.83 times 0.05. Okay, so we got 0.83 times 0.05 gives us 0.0415. Okay. Probability that a randomly selected person on trial is guilty given that they're not convicted. So the not convicted is going to have to be the 0.0415 plus the not convicted down here is 0.1683. Is guilty. So here's the guilty but not convicted, so that's the 0.0415. So we got to do that. 0.0415 divided by whatever this is added together. So we got 0.0415 plus 0.1683 gives us 0.2098. Okay, so we got to do 0.0415 divided by our answer of 0.2098, and that gives us 0.1978. So about almost 20% chance that a randomly selected person on trial is guilty given that they were not convicted. Okay. All right. Let's move on to the next one. In a factory, 3 operators A, B, and C work shifts on certain machine. Number of parts produced by A, B, and C are 25, 40, and 35 respectively. Percentage of defectives produced is 1% for A, 1.5 for B, and 3% for C. Part chosen at random. A part is chosen at random to determine the probability of blah, 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 blah. So, again, I'm thinking tree diagram is going to be our way here. So let's do that. So we've got machine, number of parts produced by A, B, and C are 25, 40, and 35. Okay, so there's, let's go A, B, and C. So this is 0.25, this is 0.40, and 0.35. Right? The percentage of defectives produced is 1% for A, so defective is 0.01. Not defective, or D prime, 0.99. For B, it's 1.5, so 0.015 for defective. And then not defective is going to be 0.985, because that's 1 minus 0.015. And then the last one is 3%, 0.03 is defective, so the parts that are not defective is the other 97%. Okay, so there's our tree diagram. This should help us out. Okay, determine the probability that it's a defective given that it was produced by B. So given that it's produced by B, so we ignore this because we know that it's produced by B, so what's the probability that it's defective given that it's produced by B? It tells us up there it's 0.015 or 1.5%, right? Okay. So part B, what's the probability that it is defective? So now we're going to have to calculate these 3 routes and add them all together. So we got 0.25 times 0.01 plus 0.40 times the defective is 0.015, and then for C it's 0.35 and the defective is 0.03. Right, so we've got to calculate those 3 out and see what we get. So we got 0.25 times 0.01, which is 0.0025. Right, and then we got 0.4 times 0.015, 0.006. Right, and then we got 0.35 times 0.03 gives us 0.0105. So we add those all together and we get 5, carry the 1, 6, 7, 8, 9. Nothing to carry there. So it's about 2% for that one. Okay, 0.019. Okay, part C is it was produced by B given that it was defective. Okay, so we know that this is the total probability that it'll be defective. So now this becomes our denominator because we're only looking at the defective pieces. So we got 0.019, and the probability that it was B is 0.006. So we just divide those two. 0.006 divided by 0.019 gives us that it was 31.6 or 31.6%. Either one of those. Again, this you can turn into percent, and that you can pretend that you could turn into a decimal or whatever you want. Okay? Okay, last one. 13. The probability that a randomly selected person over the age of 50 has bowel cancer is 0.007. Probability that a person over 50 reacts positively to a medical test to detect bowel cancer is 0.973. If the person has it, and 0.017 if the person does not have it. A person over 50 is selected at random. What's the probability of the person? Blah 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 blah. Okay, so again, we're looking at some tree diagrams here. So probability that they have, this is cancer. So this will be our 0.007, and then this is going to be our not cancer, so that's going to be 0.993, right? Because that's the complement of 0.007. The probability a person over 50 reacts positively to a medical test to detect bowel cancer is 0.973 if they have it. So then the test, we got the positive test, is 0.973. So the react positively to the medical test, so not reacting positively to the test is going to be 1 minus 0.973, right, which is 0.027. Okay. And then if the person has it, let's see, and 0.017 if the person does not have it. Okay, so reacts positively to the test and not reacting positively to the test. So that is 0.017. So then this will be 1 minus 0.017 gives us 0.983, 0.983. Okay, that should hopefully help us out. What's the probability that this person reacts positively to the test? So here's the test result. So we're going to have to do this one and this one here. So we got 0.007 times 0.973, and then we also have this one here, 0.993 times 0.017. Okay, so let's calculate what those are. 0.007 times 0.973 gives us 0.0068. Okay, and then we got this one, 0.993 times 0.017. 0.169. Let's see, we don't 4 decimals there, so 1, 2, 3, 4. So we'll do 0.169, yeah. Okay, so if we add those two together, we got 0.0068 plus 0.0169. That's that 12. Let's see, 13, 2, 0.0237 is what we're coming up with, and that is what we're hoping for. That's the right answer. Okay. So this was all for part A. Okay, so we'll call that A there. And then let's do BI. What's the probability this person has bowel cancer given that he or she reacts positively to the test? Okay, so reacting positively to the test is this here. So that's our denominator, because it says given that they react positively to the test, so that's 0.0237. What's the probability that they have the cancer? So that would be this one up here. So it's 0.0068 divided by 0.0237. So we got 0.0068 divided by sorry, 0.237. And that gives us 28.7 if we round that off, right? So we get 0.287 or 28.7%. And then has bowel cancer given that she reacts negatively to the test. So if we're doing BII, we've got this here. So we know that here's the two reacts negatively to the test. So that needs to be the complement of this here, right? Because these are the people that reacted positively. So the people that react negatively and the people that react positively should add up to 100. So let's do 1 minus 0.0237. And that gives us, oops, missed that, 0.9763. Okay, so those are the people that react negatively to the test. And then how many of those that react negatively to the test have cancer? That's going to be this group here, negatively, that has, given that they reacted positively to the test, how many of them have cancer? So that's going to be this one. So that's going to be the 0.007 times 0.027. That's going to be a really small number. Okay, 0.007 times 0.027 gives us, wow, got to move that decimal back over 4 spots. So 1, 2, 3, 4. Got 3 zeros and a 189. 189, right? So nice part about this is we can just do, hey, let's divide that by 0.9763, and we get, again, a really small number, which is good. Move that 1, 2, 3, so it's 0.0001. Let's go 0002. 0.0002 for that part there. Okay, and that is correct as well. All right, so that is all of 14K. Okay, if you have any other questions at all on this, please feel free to ask. Thanks.